I'm going to model for you how I can divide two fractions. Now, when we teach students who are working with whole numbers what division is, we often have them think that 8 is broken down into groups of 2, or really how many groups of 2 can make 8. This thinking is very helpful when thinking about division of fractions, because thinking about how many quarters make a half is a little bit easier than thinking about a half and breaking it into quarters. What I'm going to do right here is, you'll notice I have a number line that I've taken, and I have 1/2. I'm going to take that half and I'm going to break it into as many quarters as I can. In this case, I know off the top of my head that 2 quarters make a half. In the stay, change, flip rule, the way this works is we take a half, stay, the division changes to a multiplication sign, and the flip is the 1/4 flips to become 4/1. And when we multiply across, we get 4 halves, which then becomes 2. There are 2 quarters in a half. This gets much trickier when we think about fractions that aren't exactly going into each other in a whole number of times. For example, whereas in this, a fourth goes into a half 2 whole times. Here, a third is not going to go into a half a whole number of times. So what I've drawn here is a rectangle that's cut into a half, and then a rectangle that's cut into thirds. Visually, what I'm going to do is I'm going to actually overlap these, because what I want to think is how many thirds make a half. So here is a half drawn on my thirds. And what you can see is that 1 whole third and a half of a third create 1/2. So now we're saying that 1.5 thirds can make a half. And when we use the traditional algorithm for this, we stay, change, flip, multiply across, and we get 3 halves, or 1 1/2.